we will start with a point that is called as the net filtration rate. Okay, so in the last video we saw what is the structure of nephron, okay, and what are the types of nephron. Today we are going to study what is net filtration rate. Now we all know that the filtration takes place in the nephron. The filtration or the blood, it comes from the afferent arteriole. The blood gets filtered from the tuft of capillaries, which is called as the glomerulus. Okay, from the glomerulus the filtrate comes into the Bowman's capsule. It goes to the proximal convoluted tubule. Then it goes to the descending loop of Henle. From the descending loop of Henle it goes to the ascending loop of Henle, and then finally goes to the distal convoluted tubule and then collecting duct. From the collecting duct, okay, it goes to the duct of Bellini. From the duct of Bellini it goes to the renal pelvis. From the renal pelvis it goes to the ureter, and from ureter it goes to the urinary bladder. Okay, so now what is basically net filtration rate? Now when the blood comes into the kidney, okay, basically the artery, it divides into many arterioles. We saw that there is an afferent arteriole which brings the blood for the filtration. Now when that blood is coming for the filtration into the glomerulus, it has some pressure, it has a high pressure, and that pressure of arteries is around 100 mm Hg. Okay, now this blood comes with a flow that is 100 mm Hg. Now when the blood comes into, okay, the when the blood comes from the arteries, the pressure is 100 mm Hg. Once the blood comes from the arteries, it is going to come in the glomerulus. Okay, this glomerulus, okay, now the blood that is coming into the glomerulus, it exerts a pressure in the glomerulus. That pressure is called as the glomerular blood hydrostatic pressure. Okay, in shortcut you can also remember GBHP. Okay, so when the blood comes into the glomerulus, it is going to exert some pressure. This pressure is necessary so that the filtration can happen. Now this pressure is 60 mm Hg, that is 60 mm of mercury. The arterial pressure is 100 mm Hg. The glomerular blood hydrostatic pressure is 60 mm Hg. Now we have talked about the glomerular pressure. Now the next pressure is in the Bowman's capsule. Okay, let's not go to Bowman's capsule. Let's be in the glomerulus only. In the glomerulus, when the filtrate or when the blood comes, okay, this blood is going to contain the proteins. Okay, these proteins will not be filtered from the glomerulus, and the proteins are going to exert an opposing force to the glomerular pressure. This pressure which is exerted by the proteins against the glomerular pressure is called as the blood colloidal osmotic pressure, which is 32 mm of mercury, that is 32 mm Hg. Okay, so three pressures we have studied. One pressure is the pressure by which the blood is going to come into the glomerulus from the arteries, which is called as the arterial pressure. It is 100 mm of mercury. Then in the glomerulus the blood is going to exert some pressure. That pressure is 60 mm Hg. To this pressure there is an opposing pressure, that is the pressure which is exerted by the proteins which cannot be filtered. Okay, then that pressure is the blood colloidal osmotic pressure, which is 32 mm Hg. And the last pressure that remains is the capsular hydrostatic pressure. What is capsular hydrostatic pressure? That we have to study now. Now what is capsular hydrostatic pressure is, we know that this one is the Bowman's capsule and here are the capillaries. This one is the afferent arteriole and this one is the efferent arteriole. When the filtrate is formed in the Bowman's capsule, this filtrate is going to exert a pressure to the membrane of the Bowman's capsule. So from downside there is a pressure that is towards the membrane of the Bowman's capsule, and this pressure is also against, it is working against the glomerular pressure. Glomerular pressure is over here, which is 60 mm Hg. The proteins which are present in that blood, it is also exerting a pressure which is 32 mm Hg. Then the filtrate which is present in the Bowman's capsule, that is also exerting a pressure, that is a negative pressure, and that is called as the capsular hydrostatic pressure, which is 18 mm Hg. Okay, so I hope we are clear about what are the different types of pressures that are working. Now to find out the net filtration rate, we have to understand all this. We have understood all this, and now we will put it into the formula. The net filtration rate is equals to the glomerular blood hydrostatic pressure minus, okay, these two pressures, that is the negative pressure, because they are working against the glomerular blood hydrostatic pressure. That pressure is the blood colloidal osmotic pressure plus the another pressure, that is the capsular hydrostatic pressure. Now let's calculate. GBHP is 60 mm Hg minus this is 32 plus 18, so it becomes 60 minus 50 is equals to 10 mm Hg. Okay, so 60, 32 plus 18 is 50, so 60 minus 50 is equals to 10 mm Hg. Now this is the pressure, that is the net filtration rate by which the filtrate is going to form continuously. This formation of filtrate is the ultrafiltration process. So this is about the net filtration rate. In the next video we will discuss about the the different processes that happen before the urine is formed, okay, and those processes that happen in nephron, those processes, okay, which is called as the ultrafiltration. In ultrafiltration, there are three phases. One is ultrafiltration, the second one is reabsorption, and the third one is the secretion or the tubular secretion. And after this, the urine is going to get formed. So in the next video, we will discuss that in detail. This was about the net filtration rate, which is 10 mm Hg. Okay, let's see what is GFR. Okay, we saw what is net filtration rate. Now we will study about what is glomerular filtration rate. When the blood comes into the glomerulus, okay, per minute the filtrate is going to get formed. Now how much filtrate is formed per minute? That is also the question. So it is 125 ml, okay, of filtrate is formed per minute. So throughout a day, around 180 liters of the urine is formed. But now we will see about the filtration fraction. Now what is filtration fraction? The fraction of the plasma that becomes the filtrate, okay, that is called as the filtration fraction. We all know that per minute 125 ml of the fraction of the filtrate is formed, which is called as the GFR. So we have to put that into a formula. Filtration fraction is equals to GFR divided by the plasma flow. Okay, how much is the GFR? We know that GFR per minute is 125 ml. So 125 ml divided by plasma flow. Plasma flow is 650. So this becomes 19.2%. Okay, so 19.2% is the filtration fraction. I hope we are clear about this. In a normal individual, the filtration fraction is 15 to 20%, and the filtration fraction is always given in percentage. What we have calculated is 19.2. In an average person, it can be between 15 to 20%. So that is about the net filtration rate, then the glomerular filtration rate, and then the filtration fraction. In the next video, we will study about the ultrafiltration, reabsorption, and the tubular secretion. Thank you very much.